Hi guys. Well, this is the fourth session. I think this is the last second session. We have one more session after this. In this particular session, we're going to look at something very interesting. It's called symmetrical graphs and what causes symmetry in graphs. That's what we're going to analyze today. All right. So first, let's try to understand what is the meaning of symmetry. Well, that's about me skipping this part. Well, so what is symmetry exactly? If you look at Wikipedia, and this is what I've just copy pasted, well, there is a two-sentence definition given to you over there. You might make some sense of it, but in simple layman's terms, in very simple language, it is basically if you can find the mirror in a graph such that one half of the graph is a reflection of the other graph, then you call the graph to be symmetric. Once again, in the given graph, can you find an imaginary mirror such that if you take that mirror, then one side of the graph of that mirror becomes the mirror image of the other side of the graph. Let's take a few examples to understand what I mean. Let's look at this. First, if you look at this graph, let's not worry about what is the equation. It's just a graph. You can see that this y-axis works like a mirror, because this right hand side is exactly symmetrical to my left hand side. It's like a mirror image, right? So whatever point is here, exactly on the opposite side I have another point, which is what a mirror does. A mirror basically projects. If one thing is here, it will appear as if there's another thing on the other side at the same distance. That is what a flat mirror does, right? So that is the meaning of a symmetrical graph. So here I can find a mirror and the y-axis. Let's take another example. Another example over here. You can see that once again the y-axis acts like a mirror. Every point here has a equal mirror image. Every point on the graph has an equal mirror image, and the mirror happens to be the y-axis once again. Let's take another example. Now, where is a mirror in this? Take a look. Pause. You can pause the video and think about it. But for those of you who already got the answer or could not get the answer, the mirror actually is, think of an imaginary line like this. Okay, this is your imaginary line and this happens to be the mirror. And why is this the mirror? Because you can notice if this is the mirror, then every point here is the mirror image over here. Every point here is the mirror image here. Every point. Clear? That's basically what a mirror image is. So this is your mirror, and hence you can say this graph is also symmetrical. So a symmetrical graph is such a graph which has an imaginary line about which the two halves of the graphs become symmetrical, or they become mirror images. If such a graph or if such a line exists, then you can call the graph as symmetrical graphs. So why do we get symmetrical graphs? How are symmetrical graphs usually existing? Let's take a look and understand that. So to understand this symmetry, let's look at one type of function called an even function. Now, a function whose f of x is same as f of minus x is called as an even function. Now remember, anything which has f of x and f of minus x becoming same, such f of x is called as an even function. Now observe this kind of a function carefully. It means whether you put x, that is your original answer, or you put minus x, which is what this is, they are saying they are both same, which means the graph is the same. What does it mean? It means whether you put positive x or negative x, the output is the same. So right side of your origin or left side of your origin will be the same. That is the meaning. Whether you put positive x or negative x, the y is same, which means the graph is supposed to be symmetric about y-axis, or y-axis is your mirror. Let's take an example and try to understand. Okay, what is happening in this? So if I take f of x as I don't know, x square plus 1, then x square plus 1 will be a graph like this. It will be a parabola, somewhat like this. Okay, it is supposed to be symmetrical. Okay, this is 1. Now whether I put positive x or I put negative x, my output is the same. And clearly this is an even function because f of minus x will also be x square plus 1. So it doesn't matter whether the input is positive or it doesn't matter whether your input is negative. The output is still the same. And such a function always is called as an even function, and it will be symmetrical about your y-axis. So let's take a few more examples to see about symmetry. Let's take this function f of x as 1 by 1 plus x square. Now this is how the graph looks like. F of x is 1 by 1 plus x square. The graph looks like this. Now if I want to find f of x, another function, in fact all of these are even functions. So you can see f of minus x, if I want to find, it will again be 1 by 1 plus x square. And both of them are same. So we can see that y-axis is the plane of symmetry, or it is called as a mirror. The right side and the left side are exactly symmetrical. Same for this function. It is f of minus x. If you want to find, you will again get x power 4 plus x square minus 2. Sorry, minus x square minus 2. And you can see that f of x or f of minus x, which means whether you put x as positive or whether you put x as negative, the output is the same. It can be positive or negative output, doesn't matter. But if it is positive on the right hand side, it will be positive on the left hand side. If it is negative, you can see this entire part is negative, so this entire part will be negative. So even functions are always symmetrical about y-axis. Right? So that's about symmetry. The next kind of symmetry we're going to see is if you have f of x. If you have f of x, how do I find f of mod x? That is what we're going to look at. And what kind of a symmetry will that be? Now let's analyze if f of x is given. Guys, the difference between this and the previous one is, the previous one is the type of a function where f of x is actually equal to f of minus x. Okay, if this is the case, then they are called as symmetric functions and they are even functions. Here, I'm not equating anything. I'm saying f of x is given to me. I want to find f of mod x. I want to find f of mod x. Now, if this graph is there, the logic for your mod x is, now you know how mod x functions. Mod x, you will become, or you'll write it as x if you know that x is positive or greater than or equal to 0. But you will write it as minus x if you know that, you will write this as minus x if you know that x is negative. Correct? So basically what it means is whether you put inside as positive or negative, the x will never become negative because that's the meaning of mod x. So basically, if you look at it, if you look at any graph, let us say a graph like this is your f of x. It's not symmetrical at all. So f of mod x, if I want to find, there is no problem as long as x is positive, because we know as long as x is positive, the mod x becomes f of x itself. Because in positive means to the right side of your origin. This, if I draw with black line, this graph of f of mod x will actually be on top of it. It will not change. This will be the same graph. Correct? Now look at the negative side. Negative side, the problem is in my f of x, when x is negative, my answer is this output. When x is negative, the answer is this output. Correct? That is what is happening in my f of x. But in your f of mod x, if you put f of mod minus 2, the answer is supposed to be f of 2 itself. Which means what it is telling you is, if you want to find the graph of your f of mod x, so this is your f of mod x to the right side. This is problem, it's not a problem. But on the left hand side, you will notice that even at minus 2, while I'm supposed to get a graph like this, which is not symmetrical, it is not symmetrical. What it says is at minus 2 also, your output is same as plus 2, which means this point and this point will be the same y output. Similarly, at 3, I'm supposed to have the same 3 at negative 3 also. At negative 4, I'm supposed to have the same y as negative 4, positive 4 here. So it means you'll see that the graph will now start becoming symmetrical on the left hand side. the graph will start becoming symmetrical on the left hand side. So if f of x is known and you want to find f of mod x, the step to do that is you keep the right hand side as it is. Right hand side don't change, but left hand side just delete everything. From the original f of x, delete everything on the left side of your origin, and just bring it symmetrical. Whatever is on the right side, make symmetrical on the left hand side. That is how your graph will look. Once again, let's take a few examples to understand this. Okay, so if I take a graph, I'm drawing a random graph. Let's draw a graph like this. Now, if I draw a graph like this, this is my f of x. I want to find f of mod x. So my right side part of the graph is supposed to remain the same. So I will draw the graph like this. I'm trying to make it as symmetrical as possible. It is the same. Okay, I'm assuming it is the same. I didn't draw it perfectly, but yeah, it is more or less the same graph. But left hand side, I'm supposed to delete this part. And left hand side, so I deleted it. You can see it is blank right now. It is blank here. What am I supposed to do now? Reflect the right side over the left side. When I reflect it, I will get a graph like this. This is my f of mod x. So when you want to find f of mod x, the steps to do, first step, delete the left side part of the original graph. Left side means less than 0, x less than 0, the entire negative x-axis, delete the entire graph. Right side, keep it as it is. Then second step, step number 2, reflect your right side part of the graph on your left side with y-axis as your mirror. That's it. That's how you get your f of mod x. Very interesting, is it? All right. So that's how you get your f of mod x graph. Okay. So let's take an example and see what is happening. So if f of x is given to you as 1 by 1 minus x, then f of mod x will be 1 minus 1 by 1 minus mod x. And this graph, as you can understand, I'm supposed to first delete this part. Now only this part will be deleted because this will remain, this part will remain. Okay. And after deleting, I'm supposed to have a mirror image and a mirror image like this for remaining. So whatever is on the right hand side, I'm supposed to get a mirror image. And that's how your graph will look like actually. So you can see the left side is completely deleted, right side is reflected, and this side is reflected. So this is how you find your f of mod x. This is a very cool way of finding your modulus. So it looks, so if I ask you to find a graph of sine mod 2x minus 5 plus 6 minus pi by plus 6, you at the beginning would have got scared, but now you'll realize this is nothing but first find sine x, then find sine 2x. You know how to do this, we already discussed. Now find sine mod 2x. So whatever is here, that you apply the modulus wala funda just now that we have seen. Then you write it as sine mod 2x minus pi. And we know how to do this because we have learned f of x plus or minus a. And then the final step will be sine mod 2x minus pi plus 6. So it's a stepwise transformation. And you can see, now I told you the beginning of my session, the first session, or rather the second session, I mentioned that these small steps that we learn will help us in finding a very complex graph too. And this is how we do it. Right? That's all for this particular video, guys. In the last session, that is session number 5, we're going to wrap it up by looking at odd functions and a few other type of functions. Right? See you in the next video. Thank you.